Welcome everyone, and let's continue the session. Uh, Yesterday we have covered the various data types. We have finished the data type, like the data frame we have already covered yesterday or not covered it. Okay, but we have not read about the basic syntax of R. Okay, so today we learn about the basic syntax of the R. So let me share my screen with you. Uh, I hope my screen is visible now to you.
Yes, sir.
Okay. So I open the R and we continue the session. Okay. So today we will cover basic syntax of R. Basic syntax of R. First we see the function. Uh, we know that how to uh, we are going to use a function sub and g sub function. First one we are going to study about the sub and g sub function. Whenever we call function, we should have some round bracket over there. This function is used for substitution. Okay, as the name suggests, sub for the substitution. And here I write something. I write address. It may be anything. Because I have to use the quotes. And this is some address we have. I run it. I want to change this hyphen. These are hyphens in slash. Okay. So what I do, add one I write here, and I use the sub function, and sub function I write the pattern. You know, I want the pattern, but I want to change. I want to change hyphen, and with I want to change with this slash. I want to use the forward slash instead of hyphen, and then I will mention the data. These are the three arguments are there: pattern, replacement, and data. These are the default required arguments. There are many other arguments, but we consider only the required arguments which are compulsory to write. Okay, other are the optional arguments. They are the default, we could say. And here I am writing the add. Understand? If I run this, now we show you add one. You see what happens. What is the difference between add and add one? Yeah. The voice is not audible on
The first hyphen change to slash.
Yeah.
only the first hyphen has changed.
Yeah.
Yes.
Not the all. Okay, again I want to change. So I am taking add 2, and again I am doing sub, and I write the same thing. I just change the object. Add 1 I am putting here instead of 8. Okay, I run this and I run add 2. What I get here? The next one change now, but not all. But I want to change all the hyphen in forward slash altogether. So one by one will take more time. Okay. So there is a G sub function, gross substitution. Along with sub, there is another function G sub. G sub for the gross substitution. So I will do it at 3, and I will do the G sub. Syntax are same, attributes are same, you know, as we have used over there, the same attribute. And here I am directly taking add, not the add 1, add 2, add 3. Directly taking add. Understand? Add, you know that in add there is no forward slash. So I run this. What happened? Okay, I have not put the comma here. Just a moment. Sorry. You see, all has changed. Now we see what is the use of this in the data analytics, where we use this. So I will explain you with the data set. We have a data set, loans data set here. Okay. So first I do one thing. I have a data set in some other folder. Okay. So for that, what I will do, I don't have that data set here in this project. Okay. In this folder, I have somewhere in some other folder. So I just give one object name to that data set, which I want to capture here. Whatever the name you could write it. It is the MD I mostly use for the my data, small abbreviation. And we have to use again and again. So we always use the abbreviation, the smallest one. And I will that data in a CSV format. Okay. So I will write the read.csv and I will write the file.choose because I have some other location or I am not mentioning the location here. I just run it and I will get a pop-up window. Sometimes this pop-up window does not open here. It is on the taskbar. You see it is in the, you click here, you will get that pop-up window and here you could go to the path where the file is kept. Okay. There is launch data file. Okay. Or that is a comma separated value file. Okay. I open it. Now you see here. Here it is MD 2500 observations and 15 variables. If you want to view, you just click here. You will get the view. Here you see in the column interest rate. Okay. There is a percentage sign. And whenever we perform any analysis, mostly we should have the columns in a numeric form. Okay. Or this percentage symbol is an obstacle to convert this in numeric. It is basically at this moment, it is a character. So we have to convert this in numeric. So the obstacle is the percent symbol. So we have to remove this percent symbol from here. And then we convert them in numeric. Understand? So what we do, I will use the MD dollar. Dollar why I am getting? Because I have to select a column where I want to apply this G sub function. So that is the interest rate is a column where the percentage I have shown you. And then I assign it that function. That is a G sub function. Got it? And then I put the pattern. Pattern is the percentage, which I want to change. And I don't want anything against the percent. I just want to remove it. So I just put the quotes only without any space. And at the last, I have to show the data where I want to do it. So it is the same as return the MD dollar and the interest dot rate. So I will also write here MD dollar. Sorry. Interest dot rate. Got it? Before this, I want to show you one more thing. That is the structure of MD. So this is the structure of MD. You see, it is a character. So first I remove this, then I will convert this in numeric form. And I do it. Now I show you that data. You see there is no percentage. Got it? All the percent sign has gone from here. Okay. And again, I show you the structure. There is no percent sign, but it is still the character. So I will convert this now in a numeric. So that's very simple function. MD dollar interest. I mentioned you earlier also s dot numeric. MD dollar interest. Now I show you the structure. Got it? Numeric. Is there any doubt? Very easy. Okay. So this is the use of sub and g sub function. Is anyone has any doubt?
Sir, uh, actually, this is the first time that this is the first workshop of mine in R, and I was thinking that I mean, how do we enter the large data in R? And because what so far what we have been doing is just one two observations, doing changing and
Mhm.
all, but how do we enter large data set in R? And that is one question. And then the another question is like, how do we make this CSV file, and how do we export Excel file or any other files in R? Yeah.
Okay. So I explain you how to read the different sort of files. Okay. You may have the file in the CSV format. You may have the file you might have the file of Excel format, or you might have the file of the SAS format and the SPSS file you might have, and we have to read this file in R. Okay, so you could read various sort of files. So I explain you that thing. Okay, so for reading the basic the CSV format is the default. We don't have to run any library before reading a CSV format file. Okay, as read.csv are basic format are our basic syntax. Okay, but if you have a file which is in some other format, here I explain you one thing. I just remove this, so keep it up. And here you see I have so many files, the census data file here, and the so many CSV. One is the exercise files, but this is in this project. So I could direct access this file. How could I direct access this file? I show you. I just write a df name. One object name is very compulsory to give when you read a file. And here I am using this file. Suppose I am going to read some census data file. That is a CSV format. Syntax would be read.csv, and in quotes, it may be single or double, whatever the quotes. If you have the file in the same project, it means your working directory is here. So what is your working directory? The directory which is applied here at present, and then present scenario. So from where we could fetch the things, and fetch the data and fetch the scripts. That is our working directory. I will show you how we could see where is our working directory. It will show us that folder with path. So get working directory blank, keep it blank, just run it. So you will get the path where my working directory is at present. So my working directory is in D drive. There is a folder Cypher Analytica. In that folder, there is another folder Data Science with R. In that folder, there is another folder 1.R fundamentals. This is my present working directory. Does that make sense to everyone? Okay. Now I want to read the file from this working directory. Then I don't have to mention the path. Okay, I have to just write the name of the file with extension. So I am writing the name of the file, which is a census underscore data dot CSV. And I run it. You see, it is now in my global environment. There are 8,786 observations of active variables. So if you want to view this file, just click here. You will see this file. There are the 50 variables you are watching here. You click here, you will get other 31 to 80 variables. Got it? You have to go back, you could go back. Is there any doubt how to read the file which when it is in our working directory, current working directory? If your file is not in the current working directory, it is somewhere else, then you could either use this read underscore dot cs as read dot csv file dot choose function you could apply there. Okay. Is it clear? If it is somewhere else, but
Hello, sir.
this is for the data set and the data you are taking. Sometimes the some script is kept outside somewhere in some other folder, and that script
Hello,
is not.
sir.
Yes, sir. Yeah.
Hello, sir.
Yeah. Tell me. You're
Just
asking
can we use it for XLFR?
Excel file. I will explain
And-
that also. I will explain that also. Don't
Okay,
worry.
thank you, sir.
I will explain all sort of file we could read here, and we could write in any format also. Okay. This is the file about the data file. But sometimes we require the script also. Script is as a .r. It is somewhere else in some other folder. So we have to use this open folder. Got it? Are you getting my cursor? And we click here. Then we could read the script of kept in any folder. I just run it. So you see this script has come here, the dp with r.r. Now I could run this script here. Sometimes we require this script for our reference, and there are some functions we want to use. Got it? Any doubt? So sometimes you want to change your working directory. You have this working directory at present, but I want to change this working directory to some other place. So set working directory function we will use. What function? Set working directory function we will use. I don't use here, I use here. Set working directory. And in quotes, or it may be single or double quotes, you copy that path and you paste here. One thing. Suppose I am going to set my working directory. Here, this place. And what I do, I will just keep my cursor here on the address bar, and I just right click. I will get this pop-up window, copy address as text, edit address, delete history. I will use the second option, copy address as text. Okay, just click here and I will go to the R, and just here between these quotes I will paste it. Got it? That path is now here. Now it is if you are running Windows, then in Mac and Linux there is no problem, but in Mac but in Windows, sorry, you have to convert this backward slash in forward slash. All the backward slash you have to convert in forward slash, otherwise it will not run. Okay. Got it? Convert the backward slash in forward slash and then run it. Now I will show you my working directory. What is my working directory? So it is now changed. Previously it was R fundamentals. Now it is a data folder somewhere. Now I could read the file from this place without using file choose function. Okay. Is there any doubt? What it? So,
Sir,
yes.
sir, may we use import dataset option that is given in the software, import dataset under standard history?
We could use that also. No problem.
Okay, sir.
Here, if you click here, but it would be in the same folder now. I've changed the path here also. And I want to read some file which is in Excel format. Okay. So first I will search that file. It is the exercise.xls. This is the Excel file. I want to read it. So I am writing a ex name exercise file. And before reading an Excel file, you have to run a library, or if you don't have the that package, you have to install that package. How to install the package, I explain you. You click on the packages, look at here, and here is the install. So you just click here, and here you type the read Excel and install. It will take some seconds to install. And once you have to install only, not again and again. Every time whenever you use it, you import that package. So how to import that package? We have a command library. And here we write the read Excel. This package I have imported now. Now it is working for me. And it started working for me. I could use the command of this. So I will write the read you see here also the package name, which function you are using. So I have an XLS file, as I mentioned you. So I will select this. And then the same way, I will write that file name with extension. I will show you the files. You see the exercise dot XLS, and I run it. You see I have EX 15 observation 5 variables I could see here. You know how to read the Excel file? Okay. And if we have SAS file, so here is you see there is a gaming one state says B data. So this package you have to install. Okay. I have already that package. So I will not install says 7bdet package name. So I will just use that and I run it. So it is imported now. And this is a gaming. So GFI. So I will read dot says bdet and the same procedure gaming 1 dot says 7 bdet and I run it. You will see there is 1143 observation, 3 variables. So this is my data set. Got it? Now we want to read the SPSS file, which has a .sav. .sav is the extension. So we have a library for n. Some other libraries are also there for the SPSS file. I'm using this. And the same thing, the file name is del. So I write the D and read dot s a read dot SPSS. Sorry.
Excuse me, sir.
Yeah.
When we upload the read Excel, we have like 3 options: XLS, XLSX, and like read Excel. What is the difference in, like, how can we choose
This
any?
is the from different versions of Microsoft Excel.
Okay.
So
So we
whatever
can
the
choose either.
you could use as per that. We will get all the options over there, or we could have to install that also sometime.
Okay.
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 So
thank you.
I say that convert the Excel file in a CSV format. I will explain how to convert it. I will explain you just after finishing this small thing. Then I explain how to convert the Excel file in the CSV, or CSV is very easy to read. Okay, or it also take very small space when we read the CSV. So SPSS, so there is a del.sav file and I run it. But you see in the other files, we have got the number of observation and the number of variables. Here we are getting the list on. We are not getting the data frame. It is a list. I will show you here. Or if you want to show, you could see here. It is a list. So I want to convert this list in the data frame. Okay. So I keep the same name as data frame, data frame, and D. I run it. You see now there are 372 observation, 11 variables. Getting it? Okay. Any doubt? Now you are able to read so many files, or if you have some different format of data set file, you could also read it. You could search on the internet what command you have to use. Is it okay? Now I tell you And if you have to write some file that I explain you later on, before that I will explain you how to convert an Excel file in CSV. You see, it is a Microsoft Excel file. Okay. And I want to convert this in the CSV format. So what I will do? I will just go here and save as. If you want to change the name, you could change it. And here you see the Excel work. We have to click here. And there are CSV, this for the Mac and the MS-DOS. And there is another CSV. You will see comma delimited. This CSV we have to select, not these two. Which one? Comma delimited. And I run it. Oh, sorry, save it. And yes, I will show you that file. You see here is two files now. Previously it was one only. Or this one is the comma separated value file. It was the Excel sheet. So you see the space 36 KB, there is 26 KB space it is capturing on. And CSV file also open in the Excel sheet. Understand?
Yes.
If you open these, if you have the Excel, it would be the on the same sheet. So always convert the file in CSV format, then read it. So it would be better to work. Otherwise, what happens in the CSV, in the Excel sheet, we have many sheets in the Excel file. In default, we get the 3 sheets in Excel file. Got it? So here I have not mentioned the sheet number in the exercise Excel is. If I mention the sheet equal to 2, you see what happens. Here you see the 15 observation, 5 variables. Okay, now I select sheet 2. Change 365 observation, 17 variables now. So in the Excel sheet, what happens when you select, it is very, very important to keep in mind which sheet you are going to select. Otherwise, you have selected the wrong sheet, you will work on that sheet. Or in the CSV, when we convert the CSV, whatever the sheet we open, it will convert in CSV in the single form. Other sheet will not convert in the CSV format of that file. Okay. Only the open sheet would be converted in a CSV. Is it clear to all?
Sir, according to you, which is the best one? Where is the which is the best one where we can enter our fieldwork data? Is it Excel, SPSS, R?
CSV.
Excel, CSV.
.csv format is the best.
Okay. Thank you, sir.
Now I will like to save this Excel file EX. And I want to save is in my system as a CSV format. And it is Excel 8%. It's Excel sheet. And I want to save this. I want to save it. So write .csv. You could save in any format. So write .csv. Then I will write the name of the object. This one. Okay. Without any code. And then by which name I want to save it. Suppose I want to save it exercise CSV. Don't write any object name here when you write the file. Okay, it's just a function we have to use. And I run it. Okay, and it would be saved in my this directory, which is the working directory. Before it, I want to save this. I want to change this working directory. I have another option to change the working directory. I will explain here. I want to set the working directory this particular folder project 1R fundamentals. So I could copy and paste the name. One, I have an option. I could copy this and paste here. But I don't want to go to copy that. I know it is in the D drive. It is in the D drive in the some folder, and then I will search it out. So I will just and I use a forward slash. Sorry, I use a colon, then forward slash, and then I use the control and space, control plus space. Note it down, control space. Okay, you'll get the drop down menu of the folders. So I have that in the Cypher Analytica. Then I again control space. So I will get other. So here I will see where it is. It is in R. And then I will here I will get the R fundamentals. Got it? In this way also I could select the path. So there is already a forward slash. I don't have to change the slash now. I run it. Then I save it. And I will show you here that file. Okay, it is not that path. So I will change here path. You see here. There is that file exercise. It is the capital exercise. I show you that capital exercise. It is showing the small one. Why it is 30 KB? Why it is so? It should be in a small one. No? I just see the folder. You're getting it. Why it is taking that? I will get this file here. Okay.
Doctor, I can tell you something. If you want
Yeah.
to the right side to be modified, then you can arrange it from descending or ascending, so you can see the file. Yes,
This
it's
one?
modified. Name, size modified. To the right, Doctor, to the right. Yes, no, more to the right. There is name, size modified. Then you can see the file.
Okay. No, I was reading that the CSV one, but that exercise file is not there. What I have saved, exercise.csv, is
Sir,
here.
yes, sir, it was there since the timing created is 5:51 and date is 31st October. So that is the only same like before.
Yeah, that is why. But I have written in capital, no?
Yeah, this is new.
It should be in this name. First I remove it and we see what happens. Now it is clear. Now I could import it, but I am not importing it. No, I just view it. We could view it. Okay. It's correct now. Sometimes there is some bug maybe occur in this. So you have seen how to read the files. Any doubt now? Is there any doubt now?
No, sir.
Okay. So we again come to our main topic. Sub and G sub we have learned. Now the second function we see. Paste and paste view. Suppose we have a variable and I run this board. And I want to paste it. X, comma, Y. I run it. Got it? This I pasted. Is there any doubt? I want automatically I want one space between them. Okay. I want some other separator. The separator I want asterisk. I run this. Okay. Is that make sense to everyone? What is the paste? Okay. I will tell you about the paste 0. I just do the same thing. You see what is the difference between paste and paste 0? Can you judge the difference? Yeah.
The space.
Paste 0, there is no space.
Yes.
Okay, so that's the only. We could also use the paste function for this sort of activity. How? I will explain you. X comma y, and when you put the separator, don't write anything between the quotes, just run it. Okay, so same output you will get the paste with paste also, as you are getting with the paste 0. Okay. Suppose I want to paste this column and this column, debt, consolidated, mortgage, credit card, and these two column I want to loan purpose and the home ownership. I want to add this. Okay, paste it. So I could paste it. I just give some new name to that new column, which is the MD dollar. So I just write a new and paste 0. I am doing. Okay, paste. I take the paste. So we could read the hyphen in between. MD dollar. Loan purpose, comma MD dollar, home ownership, comma separator. I use the hyphen and I run it, and I will show you that. What? Understand? Okay. So in this way, we could use this function for manipulating the data. Next function, we have the substring. Suppose I have some IP address. It should be in the string, substring. This IP address I have, hypothetically, and I run it. Okay, so you IP, you get this. Now I want to select from here to here. I want only this string, substring I require. So I start from the 4th place. Indexing starts with 1. 4, 5, 6, 7, 8, 9, 10. 4 to 10. So I will write the substring. First I write the text where I want to use. Here the text is first, IP is first. And then from where we have to start? We have to start from 4, and where we have to end at 10. Got it? Is there any doubt? Where we use it? You see there is a column, FICO range. It is in a class interval. 735 to 739, 750 to 719. We have many use. One of I am telling you. What we do this sort of column? In statistics, if you have the column with class interval, when you solve the problem of this class interval data, group data, then what you do first? Can someone tell me?
Mid value, we can take mid value.
Correct, Surajit. We find out the mid value. So how we find out the mid value? What we do the calculation?
Both
So
extreme
adding both
plus
and divided by
by
2.
2.
Correct. We adding both and divide by 2. We take the mean of this. Understand? But it is a, if you see the structure, it is a character form. Because of hyphen, it is character. And what we have to do, we have to separate it. We have to substring it. First 3 digit we will take as a V1, and the last 3 digit we take as V2 column. V1 and V2. 2 column we will create here separate for the lower limit, for the upper limit. Understand? Okay. Then that both column we add on and divide by 2. We convert them in first numeric and then add on, then divide by 2. I explain you how to do it. I am making a new column, that is a FICO range. So I will make a F1 and F2, 2 columns for the upper limit and the lower limit. So MD $F1, and what I am doing, substring MD $FICO range. Start from 1 and end at 3. I run it and I will show you that MD, and you will see it. It is my F1. Got it? Okay. Similar, I will make a F2 for the upper limit. It will be from 5 to 7 because the 4 is hyphen. 1, 2, 3 we have taken. 4 is hyphen. 5 to 7 place. And I run it. But if I show you the structure of this, you see these are the character present. We have to convert these both in numeric. Now if I show the structure, you see these are the named. Now I could apply any arithmetical operation with this. So I'm making another new column, FICO. And this is I'm making with F1 plus F2 divided by 2 or multiplied by 0.05 also I could write. And any option. F1 not found. Correct. I have not written the complete address. It is in that data frame. It is not independent. You see. Now the column F1 and F2 has no worth for me. Have no worth for me. And the FICO dot range is also not useful for me now in the future analysis. So I will remove these three columns. Okay. So I just show you how to remove a column from a data set with R basic syntax. And I have some other package syntax also, but that will not cover here. So MD dollar echo dot range I want to remove. So I will just write the null NULL in capital and run it. It will be removed. Similarly, I will remove F1. You could remove various column altogether, but here I am not showing you that. With the help of some package, we could do that. Multiple columns we could remove. I am removing one by one. Now I will show you. There is no that FICO range or there is no F1 and F2 now. Does that make sense to everyone? What is the use of this substring function?
Yes, sir.
Now, how it is important? You think that why we are writing too much syntax for this small activity. But if you have a data of thousand of rows, then these 4 lines is not big one. Okay, it's a small code. Now we read some more function. One function is the string split. We have this string and I run it and I want to split this string by hyphen. So I will write the string split. X is my object name and I want to split it by, if I run this, you will get this thing. And if I run this function, then you get all are separate. Or what is the output? Is it vector or something else? Can somebody tell me? Is it vector?
Seems like, sir.
It is vector.
Yeah.
Which data type we are getting output?
Character?
String type.
No. Anyone else can tell me? Okay, I give some name to it. Now I show you the class of this. What is the class here?
Name.
It is a list. We get the output in list in the string split. Okay. Later on, we could convert them in vector. unlist it. You unlist it, it will convert in vector. Okay. You see the list we get always this thing, no? Double square bracket and this sort of things we get in that. Okay. Now we see another function, sequence. Sequence is, you know, that the arithmetic sequence and this all arithmetic progression.
Yes, sir.
Arithmetic series, that is the same thing here. It is the arithmetic series. The syntax is what? Start and end. From you have to start that series, and where you have to end it, and in between that. And by is for the common difference. By for the common difference. So we make a series 1 plus 3 4, 4 plus 3 7 plus 3 10 plus 3 13, and 13 plus 3 would be 16. It is greater than 15, so our series will end at the 13. So I will explain you and run this. Getting? Is there any doubt here?
So what was the type you were saying? Is it a list or something?
No, it is a vector.
Okay, so vector is a class type or some data type?
Vector, the class is a numeric. I suppose I save this and I will show you. Class would be numeric. You check in this way if you have any doubt. Okay, it is a vector of the class numeric.
Okay.
If you have to find out there is one more thing. This is by the common difference. This is by the length. Length is including these two. I want 10 length with some common difference. It will calculate itself and give us the 10 numbers which has the common difference, the same interval between them. So length equal to 10. So I'm getting these 10 numbers. It will including 1 and 50. Got it? The difference is common between all the consecutive numbers. Is there any doubt? Okay. Now another function which is a replication. Repeat. I want to repeat 5 10 times. I just run this, so I will get the 5 10 times. I want to repeat A 7 times. So I will get the A 7 times. I want to repeat AB 4 times. So I will get the AB, 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 AB. I want to repeat AB 4 times, but each 4 times. So you see the difference between both. Look at this. Got it? Is there any doubt in the replication function? No doubt. Now we see the function sample. We take the sample from a population mostly. And what is the speciality of the sample? What is the characteristic we could say for sample. Yeah. Can anybody explain me what is the sample have the specific characteristic? Yeah. Nobody. Suppose I have few numbers. I think the colors you could get better. I have these 6 numbers and I want only 3 out of these 6. How could I get 3 numbers?
By finding mean, standard deviation, and all other parameter.
No, I want to select only 3 numbers. How could I select it?
There is a option, sir. Only use of length option.
We can select using random number.
Correct. That's what I want to listen. Randomness is the specific characteristic of the sample. I am getting any 3 number. Randomly, I could get any 3 number. 15, 12, 10. I could get the 15, 12, 7. Any random number, any 3 random number I could get. Any 3. Understand? Randomly, I could get it. So, what we are going to do it, you understand here. If I write 1:10, what I will get here? 1 to 10 integers. This we have seen earlier. Okay. Again, I will run it. I will get the same. Again, I will run. I'm getting the same, but if I write sample 1 is to 10, then see what happens. Again, I get it. You see what happens. The sample 1 to 10, I was getting 162 here. I'm getting all 10 numbers, but sequence are different. Look at it. Every time I will get some different sequence. That is a sample which is random. Okay. If I want to get 5 out of this 10, so you see, every time I will get different number and the sequence. Okay. If I get this 7 out of 10 and I write the replacement true, so the numbers may repeat. You see here the 6 is repeated 2 times. Next time I run, some other number may repeat. 2 is repeating 2 times. Does that make sense to everyone? What does it mean by the sample? Okay. Now, yeah.
So replace equals to true. That means it is repeated, is it?
It may repeat the numbers.
Okay.
Repetition is allowed. We could say that. Okay. But it depends on the, when you run this, it depends on its own algorithm. It will repeat or not repeat. It may, sometimes it may not repeat any number. It will give the all different 7.
So
sometimes it will give the same number 7 times.
Okay.
It's also possible. But here, if we don't write this replacement true, it will give us the different.
Okay.
Okay.
Yes, sir. By default, it is false. You're saying that.
Yeah. Correct. Got it?
Yes, sir.
Now I have 3 ABC and I want this to 1000 times. But I have 3. Out of 3, I require this 1000 times. So replacement is very, very compulsory. Without replacement, I could not arrange 1000 times ABC. Can I arrange? Could not. So replacement is must if your data is small and you are replicating it in many times, more than that. So replacement is true, is compulsory. When you don't write this probability, suppose, and I run it, and I will show you the table. So you see the every A, B, and C, all the elements are coming nearly same proportion. Getting it? Out of 31,000, 30, 33, 33, 33%, near about. Next time I run it,
What does replace T actually do? I didn't know that.
This is the ABC we are want 1000 times.
Okay.
I will show you that. You see, we are getting this 1000 times.
What does replace T does?
Replace means the replacement, the A may be more than one time, B may be, then you could write on the 1000 times. No?
Okay.
That is called the repetition allowed. For the repetition, replacement is the, we could repeat A and B and C many times. Okay. But here what I want to tell you that if I run this and run this, so you guys, it is near about same proportion, not the exact, but nearly 33%, this much. Getting it? But I want A only 10% times, B only 20% time, and C 70% time. Then C. A 10% time, 0.1 probability. B 20% time, 0.2 probability. And C 70% time, 0.7 probability. But it will not be the exact value. Exact 100 times would be out of 1000 A, and the 200 times B, and the 700 times C. No, it will not does that mean. It is the probability. It is approximate. Okay, I run it. I will show you the table now. So A is 85, B is 217, C is 698. Next time I run, I will get some different combination. Next time I run, but it will be near about that. What proportion we have set. Does that make sense to everyone? We could control that through the probability.
So
Control the distribution.
Sir,
Yeah.
If we assign probability, it is deterministic actually.
Deterministic, correct.
We assign probability. We don't know the probability.
Yeah, we are assigning, we are controlling it, this distribution.
Yes, sir. Yes, sir.
We are controlling, somewhere we are controlling this distribution. But it is still randomized. The things are randomized. A, B, C. The sequence of A, B, C in the data, that is randomized.
Sir, this technique may be used in bootstrapping. That if we increase the data.
Yeah.
When we
Yeah,
have small number of data.
that is a small, correct. Duplicating, which we say the bootstrapping. Okay. Got it? Sometimes where we use this sample.
So 0.1, 0.2, are you assigning the type number of times it is repeating or what?
No, these are the probability, the out of 1000 observations elements we are getting, ABC we are writing 1000 times randomly. Okay.
Yeah, the probability of repeating of A is that 0.1?
Yeah, that is the probability for repeating A, how many times repeating B. But it would be randomly, you know, repeatedly randomly. It will not give you the exact that. It will be approximate. Here you see.
Close to it.
Every time you will get the different. Close to it. Okay. What we do, as you know that we have a data. Like we have read this data, MD. Okay, we have a data MD. When we get some data for machine learning purpose or the predictive analysis, then we divide the data in two parts. Okay. One is for the training purpose and second is for the validation or the test purpose, we could say. So at that moment, we divide the data randomly. It doesn't mean that the 70% data I am using for the training and remaining 30% I will use for validation or the test of the model. It doesn't mean that the first 700 observation or the 2500 to 2500 observation out of this first 70% observation I will use for the training purpose and the remaining I will use for the testing. No, I require the observations randomly. I may get the 2499 observation first, then the second observation, then some 500 something observation. And this way I want the, otherwise my model may be biased. So I want that partition in random basis. At that moment, I use this sample function. So I will show you sample. Here I am only selecting the index of the rows. I'm not selecting the whole data, the 16 variables. So I have the 1:n row in the MD. This is my data. As we have seen, this is data, and this is, as you see here, this is data, and we are selecting this 5. So this is data, and we are selecting the 70% of these rows. Whatever the n row may be, any, there is the n row is the 2500 rows. N is 2500. And I run this. And I will show you that one I got 1750 rows. First observation is 1076 number rows, then 777 number rows, then 660 rows. In this way, I'm getting this. I'm not getting first 70%. I'm getting randomly. So these are the rows numbers. And then I want the data frame for this, for training. So I could write the MD underscore train, and S I am using, not the MD. From MD, I am using as is the rows, as is the number of rows, but I have got 1700 something, comma, and I will blank it. So it will give me the all column from the MD. But rows would be whatever I have the rows in, as these rows I will get here. But column I will get all column. If I run this 1750 16 variables, now I have that data frame. And these are the rows number you see, which I have shown you here. Got it? Randomly I have selected. And what I do, next thing, now I want the data for the training purpose or the validation. So I could write MD underscore test for the testing. Remaining data, remaining 30%. Well, how I will write? I will write the minus S, which rows not in S, remaining rows, and comma. I will get this 750 observation 16 variables. Got it? Any doubt? I could not understand, Usman, sir, what one represent in this function. Can you repeat? I could not understand which function you are asking.
Last function explained as sample one column and row.
1:n row. One is the starting. We start with the one, everything. So 1:n row in the MD. MD we have 2500 rows.
And one is the starting point?
One is the starting index. 1:n row. From 1:n row, we have to, in the MD data, we have this data. And from this row, we have to select. If I write here 25 is to n row, so it will start from the 25th row. Got it?
Yes.
Suppose I have selected this today, and then I have some worked on that model. And next day, when I again start the work, again I have to select it. I have to run the script. So I will next day, if I select, today I am getting that observation I will show you for the trend. 1076 is the first observation. Right? You keep memorize it. What is the 1076? And today I am again running this. what observation I get here. 204.
That will be different.
And this is the difference. Every day
Yeah.
every time I will get the different one.
Yeah.
So it will disturb my analysis or not? Because we have a data is a variability in the data. So it will give me some wrong direction. I will get always the different direction, not the same direction I could work. Got it or not? So every time I want the same. Every time I want the same. The next day I do the I want the same random number. For that I have a set seed function. Set.seed. So I will put one set.seed function here.
So what does minus s does? Does it negate every integer in the?
No. It is whatever the observation is S. What are the observation not in S?
The rest of the observations
Rest
which
of the
we explained.
observation which we have not included in S. Out of 2500, we have included only 1750.
Okay.
So remaining observations, we are using this minus sign, which are not, which is in the MD data, but not in this as our object. Got it? Now I am using set.seed and I could use any number 1 to 9,99,999. Any number I could use here for the set seed. There are so many algorithms. It is a pseudo random basically. For every number there is an algorithm. It will give us the random. Suppose I am using 222 random. I could use any number. And I run this. So you see we are getting 254181304. Getting here. Next time I again run it, I will get the same one. If I don't use that set seed and I run it, I will get some different. With this set seed, if I run it, I will get the same one. It will not change. Got it?
So in set seed, can we give another value or it's just random value? We can give any random value, is it?
It will every set seed number, behind every set seed number, there is some algorithm of the randomness.
Okay.
So it will give the object always a same sequence when you apply a particular set seed.
I didn't get it, sir.
I
It's
will
a
show you.
suppose.
I will show you.
Uh-huh.
Just a moment. With a small example, I will tell you. If I write the 1:10, what I am getting? This. Next time I run, I will get some different sequence. Okay.
Yes.
If I use the 1, 2, 3 set seed and then I run this, again I use 1, 2, 3, then I run this. You see what happening?
Same result.
That's the thing. The seed,
Okay.
if I change the seed, I will get some different.
Okay.
Every seed has a different sequence.
So we have to keep in mind like what we have given for a certain set of observations.
Yeah. It is not a pure random. After set seed, it is not a pure random.
Okay.
It is a
But
pseudo random now. There is some algorithm which is working for that particular seed.
Okay. Got it, sir.
Okay. So that is the set seed. Sometimes we require it. If you write letters in capital, you will get the capital alphabets. If you write the letters in small,
We get the small letter.
Small letters. So I am taking one sample of letters, 9 letters. So here I will get randomly any 9 letters every time. Got it? If I use the set sheet, I will get the same letters. Got it? Okay. Now the next function is match and percent in percent. I'm writing here x is equal to kj $1f. There are 5 elements, 3 are alphabet, 1 is a specific character which is dialer, and 1 is a number. And I run it and I show you this is this vector. Another vector I am taking letters, which is the all alphabets, and I match x and y. This is my x and this is my y. I match where they are matching. So it will show me the index. This k is matching at the 11th place of y. Clear? J is matching at the 10th place of y, giving me the position where it is matching in the second vector. This 2 is not matching, so NA. F is matching at the 6th place in y. Does that make sense to everyone? Yeah.
Yes, sir.
And I use yx. So I will get A is not matching anywhere, B is not matching, F is matching at the 5th place in X. It is in the 5th place in X. Okay. And J is matching at the 2nd place in X. And K is matching at the 1st place in X. Does that make sense to everyone? Got it? Where it is matching, it guys, just show me the position. As this X and this is Y. When I return the X comma Y, match X, Y. So K is matching at the 11th position in Y. It is showing the position where it is matching. This match function show me the position where the first vector element is matching in the second element vector. It will show the position in second vector. Does that make sense to you?
Yes, sir.
Okay. Now, there is another function which is percent in percent. This sort of function is called the infix function, infix. So x percent in percent y. So it is respond me in a true and false. The first is matching, second is matching, third, which is the dollar, is not matching, one is not matching, and the last one is matching. So it will give me in the true and false whether matching or not matching. Got it? Now we have y percent in percent. If I do, so the first is not matching, A is not matching, B is not matching in this way, and this one is matching. Okay. If I want to know what is matching, in the first match function, we have seen where it is matching. In the second vector, we are getting the position. But in the percent in percent, we were getting only whether they are matching or not, true and false. But the thing I want, what is matching? So then the percent in percent we keep in a square bracket, and the first attribute we write outside also. So it will show me that X value where it is matching. What is matching? KJF is matching. If I write y percent in percent x, so I have to write this one here. So it will show me FJK is matching. Does that make sense to everyone? Okay.
Yes, sir.
Now, this percent in percent what we are getting, we know that it is in the true and false, and I'm giving some object name to this. And if I show this, it is a true and false basically, which we have seen earlier. And if I convert this in numeric, I will get 1 1 0 1. It will convert true in 1 and false in 0. Does that make sense to everyone?
Yes, sir.
Okay, so I finished today's session here itself. Tomorrow is a Sunday and we continue one more class tomorrow. And I would like to ask what time you would prefer, the same time or some other time?
It's the same time.
Same time.
Same time would be preferable.
Same time.
Okay, same time would be better. So other can, sometimes we forget if we change the time. So we could finish our work up to 5. If you have to go to market, you could go to market before that. Okay. So that would be better. So 5 to 7 we will have class, and we may be the long class today also, tomorrow, sorry, maybe more than 2 hours, because we have to finish the descriptive analysis too. Okay, so it may be more than 2 hours, maybe 2.5 hours, or maybe 3 hours session. So come in the class having some food stuff before, otherwise you will get hungry.
Okay.
It would be a long session.
Yes, sir. Yes, sir.
Okay, so thanks everyone. I think Mr. Mukesh is not there today. He is not here in this session. Okay, no problem.
Thank you, sir.
Okay.
Thank you, sir.
Thank you so much,
Thanks
sir.
everyone. Okay, thank you.
Thank you.